So usually the levels of ACTH vary throughout the day. They are high in the daytime and fall gradually over the span of the day and are lowest when you're sleeping. So as the saying goes, nothing a little nap can fix. So now we know that how ACTH is secreted and what role it has in our body. So now let's shed some light on how the levels of ACTH are intelligently regulated with a very tight-knit system within our body. We will also analyze the feedback loop and its impact on our body. Now, after the action of CRH, the anterior pituitary gland releases ACTH. This ACTH acts on the adrenal glands to produce more hormones, one of them being the cortisol. So basically, the cortisol in turn retards the release of corticotropin releasing hormone, or CRH, from the hypothalamus, and ultimately ACTH from the pituitary gland in a negative feedback loop. Similarly, high levels of ACTH will also negatively affect the release of CRH, again in a negative feedback loop. So it's so fascinating to see that ACTH itself and also the adrenal steroid hormones are regulating this whole pathway in a negative feedback loop. Now, the cyclic production and release of ACTH is also regulated by multiple other factors. So firstly, we have already seen that the free calcium in the cytoplasm of the anterior pituitary cells enhances the release of ACTH. And then we also have serotonin and acetylcholine, which are neurotransmitters. They also stimulate the hypothalamus and pituitary gland to increase the production of CRH and ultimately ACTH. Since serotonin is also termed as a happy hormone, its concentrations will obviously help to increase the stress-relieving hormone, which is the ACTH. Now, on the flip side, the sodium ions and the gamma-aminobutyric acid, or GABA, will inhibit the release of ACTH, thereby negatively regulating this ongoing loop that we have. So at a glance, the free calcium ions, the serotonin, and the acetylcholine will enhance the production of ACTH, whereas the sodium ions and gamma-butyric acid, or GABA, has a negative impact. Now, it's important to note that normal values of ACTH in our blood are almost 9 to 52 picograms per milliliter. But now the question arises, what happens when there's too much or too little of ACTH in our blood? Do you start acting anxious from all the surrounding stress or immediate threat, or you become like Hulk, full of rage? So be it any of these conditions, they are somewhat dependent on the proper regulation of ACTH. Now, this disruption in the regulation of ACTH usually results if the glands which are responsible for its regulation and production stop working normally. And these glands were the HPA axis that we talked about. So the fluctuation of ACTH in the blood will occur. And as a result, different diseases are caused. For example, the adrenal gland insufficiency or overactivity leads to hypopituitarism, and on the flip side, hyperpituitarism. So usually the adrenal gland insufficiency will lead to hypopituitarism, and overactivity will lead to hyperpituitarism. We have separate lectures dedicated to these topics. Why don't you go check them out? Now, a high level of ACTH may be a sign of Addison's disease, adrenal hyperplasia, Cushing's disease, an ectopic tumor that produces ACTH, adrenoleukodystrophy, which is a rare condition, and also Nelson's syndrome, which is also a rare condition. Now, on the flip side, the low level of ACTH may be a sign of adrenal tumor, exogenous Cushing syndrome, or hypopituitarism. So this brings us to the end of our lecture. Now, stay tuned for more lectures on the functions and regulations of other anterior pituitary hormones as well. And do not forget to check out our vast catalog of over 1,500 lectures. You will surely find what you're looking for. So that was all from me, Ifra Zahid.